Good morning, good afternoon, good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. I'd like to start off our event today by thanking Trifecta for sponsoring today's event. Trifecta is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Harness the Power of Big Data Analytics, and that'll be presented by Trifecta. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have two presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Raju Penmacha with DataRobot and Connor Carreras with Trifecta. Now, Raju has a PhD and is a customer-facing data scientist at DataRobot with close to 20 years of experience in modeling, analytics, and technology. Raju's worked for companies such as American Express, HSBC, and the Mayo Clinic on a variety of data science use cases, including recommendation systems, anti-money laundering, and big data security. Now, Connor is Trifecta's Manager for Customer Success Americas, where she helps customers use cutting-edge data wrangling techniques in support of their big data initiatives. Connor brings her prior experience in data integration space to help customers understand how to adopt self-service data preparation as part of their analytic process. She's a co-author of the O'Reilly book, Principles of Data Wrangling. So Raju, Connor, hey, thank you for being with us today. We're looking forward to your presentation. Now, from BI to AI, the need for big data and analytics is pervasive and transformational. However, big data technologies such as Hadoop or Spark are still quite complicated and not leveraged to their full capacity by business practitioners. New technologies are available to leverage the power of big data platforms for self-service data preparation and automated machine learning to help organizations get the most out of their analytic initiatives and unlock the full potential of their big data investments. So in today's Data Science Central webinar, you'll learn the essentials you need for modern data and analytics strategy, ways to expand your strategy development repertoire, and emerging approaches, as well as why big data solutions like Hadoop and Spark are ideal for machine learning and advanced analytic initiatives, what automated machine learning for big data is and how it can change your approach to machine learning, how self-service data preparation reduces the work required to deliver clean data at scale for predictive modeling, and how to leverage big data platforms to rapidly deliver more accurate predictions for machine learning initiatives. So Connor, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
All right, great. Thanks, Bill. So let's get started. I think when we're talking about big data and analytics, a lot of what we initially think of is the vision of a data lake. And you've probably thought a little bit about a data lake or heard your IT department talking about their data lake. And really the vision for the data lake is that everybody in the organization can have access to clean, standardized, easily available data sources. Now, unfortunately, what we've seen in enterprises is that a data lake looks more like the image you see on the screen. It's very much frozen over and largely inaccessible to the business. Now, part of the reason for that, largely I think the primary reason, is that the tools required to access data in a lake up until today have largely been fairly technical and complex. They're outside the range of what a typical business user or analyst is able to utilize. And so largely the business ends up like this woman standing on the edge of the frozen over data lake. You see all the promise, but you're unable to really make use of that data. Now, again, if you think of the average makeup of data professionals, this first slide shows sort of the counts of professionals in an average organization. And it's not to scale. Some organizations may have more data scientists than data engineers, and of course you may not have 5 times as many business analysts as data scientists. But it's a rough approximation. For the most part, in an organization, most of the data professionals are business analysts, data analysts, or SQL analysts. Any data scientists on this call, you're probably well aware of being called a unicorn. It's a much rarer skill set inside companies today. And of course, the data scientists, the data engineers, again, this isn't to scale, but the darker color that we've overlaid over those first charts represents the technical skills. So for the most part, data scientists are very technically skilled, same with data engineers. But if you look to the right, the business analysts, even though there's the most of them in the organization, they tend to have a lower level of technical ability than the more rare data scientists or data engineers. And that's really part of the challenge that Trifecta and DataRobot are addressing. If you look at this next slide, we've gone and filled in those gaps. And what you'll understand from this slide is that Trifecta and DataRobot allow someone who is less technical to actually be able to make use of data in that lake. So it helps you bridge the gap between your current level of technical skill and what you really need to become productive with data. And with that, I'm going to hand things over to Raju to talk about sort of the traditional data modeling pipeline.
Thank you, Connor. I appreciate it. So in this slide, you see how a legacy data modeling pipeline looks. As you can see, data is ingested from various sources into a Hadoop data lake. And this work is done mostly by data engineers and SQL analysts. After that, data is prepared and models are built. That work is done by data scientists. The third step is where the final model is pushed into production. Model monitoring also happens here. This work is again done by data scientists and data engineers. And the fourth step is where business makes use of these predictions. As you can see, there is a huge dependency on several actors and quite a bit of dependency on data scientists. The modern way and a very efficient way of doing a data pipeline is to empower business users through self-service tools. As you will be seeing soon, tools such as Trifecta and DataRobot can help a business user to handle boxes 2 and 3 that are shown here. And they can use it on their own, then waiting for a data scientist or a data engineer to be available. Now, Trifecta helps you with data preparation, while DataRobot helps you with the modeling works. We will show you today how these tools will simplify all of this for a business user. Please also note that the model accuracy and outcome is only as good as the data that is supplied to the model. The next few slides will discuss automated machine learning and DataRobot. Here is a famous quote from Elon Musk. He says, companies have to race to build AI or they will be made uncompetitive. Essentially, if your competitor is racing to build AI, they will crush you. This plot shows you how demand for data scientists outpaces supply. So here is the demand, and this is the supply shown on a time line. Now, the way to fill this gap is to either increase the productivity of data scientists or to enable citizen data scientists. So today we will show you how that can be done using tools like DataRobot and Trifecta. DataRobot is a company that is founded in 2012, and it's a well-funded company. So far, more than 500 million models were built using this platform. We have more than 200 data scientists and engineers out of the 350 plus employees. 4 of the #1 ranked data scientists on Kaggle at one point or the other worked at DataRobot, and they had finished in the top 3 more than 50 times on Kaggle. We serve verticals including insurance, banking, healthcare, fintech, and many more. This Venn diagram shows all required skills to create this unicorn called data scientist. It requires programming skills, math and stat skills, and domain expertise. It's almost impossible to find many people that have all these skills. So how can you solve this problem? DataRobot is an automated machine learning platform that requires no programming skills, nor any math or stat skills, which means any business user, like your business analyst or an engineer or an executive or an IT professional, can use DataRobot and work like a data scientist. Connor, back to you.
Great. Thanks, Raju. So Raju has just taken you all through how DataRobot can help enable everybody to become data scientists. Now, of course, this is great if you have clean data, if all of your data already has all of the features you need to model. But unfortunately, in the real world, that isn't always the case. And that's where data preparation, or specifically a tool like Trifecta, comes into play. So we consider data preparation to be the critical enabler to robust models. So we've put the funny quote about the 80% of time that you spend cleaning data. The funny quote is, of course, that 80% of data science is cleaning the data and 20% is complaining about cleaning the data. Although this is a little bit humorous and trivial, it's actually very accurate. Most of the time when you're working with real-world models, the data that you have isn't perfectly ready to be used as is in your modeling process. You need to do some cleaning, some manipulating, even a little bit of feature engineering in order to get everything into that data that you need. We have created a product, Trifecta, that is really designed to take that 80% time, so all of the time that you're spending today cleansing and structuring and blending, and allow you to reduce that significantly. We've got 3 core principles that we believe allow Trifecta to help you do this. Those are empowering people, improving efficiency, and aligning with enterprise IT. And you'll see how each of these come into play during our demo in a moment. We have an obligatory marketing slide, sort of talking about how Trifecta is the established leader in data preparation, both in terms of rankings from the media, from analysts, the number of customers, platform support, and also analytics ecosystem integrations. So if you're thinking of data preparation, you really ought to be thinking of Trifecta. And finally, we talked a little bit about data preparation, data science. How does this all look back in our original data lake concept? So if you're building out a platform for advanced analytics, and this platform could be in the cloud, it could be on premises, it could be a hybrid environment of those 2 platforms put together, what you're really going to see is at the bottom all of your data sources getting ingested into that centralized location where everybody can access and leverage them. You then have the data preparation layer, and we've labeled that as Trifecta in this image, allowing you to make use of that data, access it, standardize it, cleanse it, structure it, and ultimately feed that data into DataRobot to build your models and get real business value out of your data. So with that brief introduction, we're actually going to show you how these 2 tools work and how you can use Trifecta and Data Robot to more quickly prepare your data and build interesting models. So I'm going to share my screen. We're going to start with Trifecta so that you have an understanding of the full workflow. So going actually from the source data through the cleansing and preparation process all the way to the modeling. So our demo that we've put together actually uses data from Lending Club. So this is publicly available data that you can go and download on your own and try this yourself. The goal here is to take this member loans information. We're seeing a preview of this on the screen right now in Trifecta, and combine that with some information about the members themselves. So you can imagine if you're building a model, there's probably some interesting demographic information contained in the member info file. Our end goal here is to be able to create a model that, using the member loans data and a little bit of the member info, is able to predict which customers are going to default on loans. So let's dive into Trifecta. I've started by creating two data sets out of the member loans and the member info files. And I've also created two recipes. Those are those circular icons that you see on the right here. The recipes are what will contain all of our data preparation and data cleansing logic. So let's jump right into things. I'm going to start with the member loans file. So I'm going to open that up right now, and you'll see this will take us into the main Trifecta interface, what we call the transformer grid. Now, if you're thinking of data preparation for modeling or for machine learning and data science, there's really two key benefits of Trifecta or of data preparation cleansing. You want to be able to quickly identify problems with your data that are going to throw off your model, and then you want to be able to correct those problems. So in Trifecta, we've built profiling into the interface. You'll see at the top of each of these columns, we're collecting two different types of charts. The first chart, that's these vertical bars that I'm hovering over right now. Our marketing team calls this a histogram. I know that all of you data scientists in the audience, you may be looking at some of these charts and going, well, those aren't all histograms. What are you talking about? But that's just the term that we use in Trifecta. But really what this shows you is how the data in each column is distributed. So you can really quickly understand, are there outliers? Are there values that you're seeing that you aren't expecting? Really get a sense for the shape of your data. The second bar, that's this horizontal bar. We call that the data quality bar. So it's actually based on the data type of your column. So you see on this funded amount column, we have an integer type. And this will tell you how many records are valid, how many are invalid, and how many are missing. So it's a really quick way at a glance just to make sure that your data is 100% valid, that you're not getting string values in an integer column. Again, that's something that could really mess up your modeling downstream. So let's actually start preparing this data. I'm going to scroll over and find our loan state column. This is the column that we want to use to create our target variable. Creating the target variable, as you guys know, is a really essential part of making your model. You need something to predict. So if we look at this loan state column and examine the profile information, we've got 5 categories here. That's represented by the 5 bars in our column level histogram. If I brush over each of those bars, I can see the exact values that those represent. So we've got current, fully paid, late, charged off, and in grace period. So that's probably too many values to predict. Really what I care about are 2 chunks of values. Is the loan good or is the loan in default? So this is very easy, very quick to do in Trifecta. Up until now, we've focused on profiling and sort of understanding your data. The next step is always taking action, producing transformations or steps based on what you've understood from the profile. So you'll have noticed that there's a toolbar at the top of the screen. This toolbar contains quick shortcuts to a variety of the transformations available in Trifecta. What we're going to pick here is the conditions. Specifically, we're going to choose case on custom conditions, or actually case on single column. Either of these options work. Once I click on that option in the toolbar, I get a very easy-to-use formula builder. So if you think of trying to do data preparation or data cleansing in code, often what you're doing is writing your line of code, producing your full program, running it, crossing your fingers and hoping that you've caught everything. What you're going to see here is as I fill in the boxes in this conditions builder, I'm actually going to get a real-time preview showing me exactly what this formula is doing to my data. So I'm going to just start filling this in. The column I'm evaluating is loan state. The first case, the value I'm looking for is current. And the new value I'm going to put in is 1, or actually 0. So notice as I changed my mind, entered 0 instead of 1, in the data, this yellow column, this preview, actually updated in real time. I can add a second case. So my other good column, or good value, is fully paid. I'm also going to enter that as 0. And our default value is 1. We're going to then call this column is bad. So this is identifying our bad loans, tagging them with a value of 1. When I click Add, you'll see that column gets created, and I've also generated a new step in my recipe. So our next operation here, I talked earlier about the member loans and the member info files. We want to combine those two files together so that we get a large number of possible features that will impact our model. So to do that, I'm going to perform a join. Once again, I can easily access the join from the column toolbar. I'll click on this Venn diagram icon to trigger the join interface. And then I'll just choose the member info file. I'm going to generate a preview of this file just to make sure that this is actually what I want to combine. And just scrolling through, that looks right. I'm now going to click on Join Keys. What you just saw happen was Trifecta attempting to guess the right join keys between these two data sets. So this is another big time saver in reducing that 80% of time that you're spending preparing and cleaning your data. Trifecta will actually examine all of the columns in the two data sets that you're joining and try to guess which of the two columns are the most likely keys. Now, as you'd expect in this demo, we did guess the correct key, member ID. But of course, if it happened to be wrong, you can always go into the join keys themselves and further customize the match. I'm just going to select all of the columns from both data sets. You'll see that I'm just clicking all the columns in the left. I can examine the preview, make sure I'm getting everything I need, and then I'm just going to click Add to Recipe. Now, if I wanted, I could do a little bit of further cleansing. There's things in here that I know I could clean up a little bit, maybe extract out these percentages, turn this into a numerical column instead of a categorical column. I can do that easily just by selecting the values I care about. You'll see Trifecta will actually build out the regular expression for me, so I don't need to muck around with code, try to remember all of my regex rules, and spend hours and hours getting that right. I can simply accept the suggestion that Trifecta came up with, and just like that, I've created this DTI1 column. At this point, for the purposes of this demo, I've done enough cleansing and blending that I'm ready to use this in my model. So to do that, all I need to do is click Run Job. This is going to generate an output file, in this case a CSV, that can get piped directly into Data Robot so that I can begin building some models. With that, I think this will complete in a second. I'm going to hand the demo over to Raju, and he will show you how Data Robot can now take our prepared cleansed data and begin creating some models.
Thank you, Connor. So I'm going to share my screen with you, where I will show you how to input the data file that Connor had just created into Data Robot and build some predictive models. So this is the screen, which is the Data Robot's application page. So what we do is, in this case, we are going to pull the data file that Connor had prepared and sent it over to me. I'm going to pull that file, which is a CSV file, and load it in here. If you notice on the right-hand side, it's loading the data. And in addition to being able to pull it from a CSV file, we could also, in case this file is shared on a database or even on Hadoop, we will be able to pull it from those sources as well. Now you'll notice that it has finished reading the raw data file, and it's doing some simple exploratory data analysis, which it has just completed. It's asking us to select a target. In our case, the target, and these are the columns that it had loaded. The target is the is bad column. So we'll pick that as a target. And you'll notice that it had loaded that and is showing us a histogram of how these loans are separated. For example, there are about 85% of these loans were good loans, where is bad is 0, while about 15% of them were bad loans, like the subprime type. Now, before I press this start button and get it going, I want to show you that DataRobot had put some guardrails in place where it does things that any data scientist would do in terms of doing cross-validations and things like that, so that there is no overfit. So let's go ahead and press the start button and start running the models. Now on the right-hand side, you will see it preparing the data for cross-validation and so on. At this point, I would like to explain to you a concept called blueprint. In DataRobot, a blueprint is basically workflow that involves some data preparation and then feeding that into various open source algorithms and some of DataRobot's own algorithms. And this entire thing is called blueprint. And we have about 200 plus blueprints available. However, depending on the data set that is loaded, it's going to pick 30 or more blueprints and start running those models on the data that is loaded. Now on the right-hand side, you will notice it has started doing that. You can see a Eureka model, and these icons will tell you what kind of a model it is. For example, this is scikit-learn's Python model. If you scroll down a little bit, we will also see some R models. This robot symbol is DataRobot's own ensemble type models. We also have Google's TensorFlow and Microsoft's Wapol Wabbit and so on. In here, there is this button which we could crank up by just clicking it, and that will allow me to expand the number of nodes so that these algorithms can run parallelly, in this case, up to 20 nodes. Right? So let me now click on this Models tab. This is a place where, as these models are being built, they get populated here. And we have this notion called leaderboard. So the concept of leaderboard is where, as models are built, the best models go to the top of the leaderboard. Right? So that way, as these algorithms are continuously running, you will have them loaded in here, and the best models, as they come to the top, you can click on them and see some details. Now, what DataRobot has done is it has made sure that there is transparency in all the work that we do. So, for example, if we click on this model, you will notice that you can see a blueprint, the one that I was referring to earlier. So if you notice, handling missing data and so on, and then it is fed into the algorithm itself. And you can click on any of these boxes, and it will show you extra details. So you click on docs in this case. In this case, it's explaining us how random forest classifier works. You can scroll through it and understand its parameters, and it even gives some references on various papers that were published on this algorithm. So what I have done is I have built these models before this presentation so that we don't have to wait a few minutes for them all to complete. And I have it here. So this is the same data set. Everything is exactly the same, except that the autopilot has finished. So in here, some of the Blender models have come to the top of the leaderboard. However, for ease of explanation purposes, I'm going to pick a non-Blender model that stood out to be the best model. In this case, this is the extreme gradient boosted tree classifier. So click on it. This has a much more complicated blueprint than the random forest we were seeing earlier. But it's going to do the same, except that here it's also handling text variables, and we do various pre-processing on the text variables, such as doing bag of word models, building unigrams, bigrams, trigrams, and so on, and then fitting all of them into a gradient boosted tree algorithm. Right? So in addition, there are a few other things that you would like to do as you use a tool like this. For example, after you have built a model, you want to see how good this model is, right? And for that, we have things like a lift chart. A lift chart is a concept where we take all the predictions and then we stack them. The way we stack them is we divide that, we take 10%. In this case, there are 10 bins. So on the x-axis, these are bins. So we take the top 10% of the predictions, put them here, go to the next 10%, and so on. And on the y-axis, you see the probability of a lone going default in this case. Okay, and the blue line here is the predicted, whereas the orange line is the actual. As you can see, there is a reasonably good match here, and so that it tells you, how good or not so good your model might be. There's also this concept of ROC curve, where I won't spend too much time, but here you can see the AUC of your model. In this case, it's about 0.69, and you can see the confusion metrics and so on. Let's also look at some interesting things here, such as feature impact. Feature impact is a concept, feature effect, well, I'll show you both of them, but feature impact is a concept where in this case, there are various features that are helping us in predicting whether a loan is good or bad. And this plot here shows you which features were most important and in a relative sense. Interestingly here, you'll find the description, which is a free-form text in this Learning Club data set, seems to be the highest correlated on the loan outcome, followed by annual income, interest rate, title, and a few others, grade, purpose, loan amount, and so on. So let's dig a little further on description. In Data Robot, if you go to this tab called Insights, you see various types of insights here. We'll spend a minute on this word cloud that pick the description column, but you can pick even any other text columns that are available. And this is basically a color-coded word cloud, where the size of the word is represented by the frequency of the word. And in terms of the color coding, the red ones would indicate its correlation of the word to a loan that's going bad versus a blue one where the loan is a good loan. If you notice, some of the things like if somebody is taking a loan for a business, maybe a small business in this case, right? Or if somebody says, help, these are things where you want to avoid such loans. However, if someone is paying a credit card or something for a home and so on, these seems to be good loans. So let's go back to the model, and I would like to show you the other one I was talking about, which is the feature effects themselves. So this is a concept where we show you partial dependency, which means what's the effect of each feature on the outcome, in this case, whether the loan will be paid off or not. Right? So in here, we are showing what the effect of annual income is. So this is a partial dependency plot, where on the x-axis, let me remove the log scale. That was the wrong button. So I'll remove the log scale, and on the x-axis, you will see annual income that's ranging from 20K to 180K plus. and the y-axis is the probability for a loan to go default. As you can notice, as annual income is increasing, the probability for default is reducing, right? And please note here that below 40K, the probability for loan default is like higher than 18%. Okay? So like that, you can see the effects of various things. For example, here, as interest rate is increasing, the loan default probability is also increasing. So you could look at each parameter like that and then see how each of them is affecting the loan outcome. Now, after you build a model, and let's say most of the times you pick the top model in the leaderboard, then you would like to make a prediction. So in order to do that, you go here, and Data Robot allows you to simply drag and drop your test CSV file in here, and you can make predictions. In addition, Data Robot also allows you to call a REST API. So I will just show you an example here. So this REST API is something that's really appreciated by our clients because it allows them to simply call a web service. What I'm showing you here is a Python example, but it can be done using Java or any other language. And all you do here is give like a project ID, model ID, and then call the web service endpoint, and you can make predictions. So the good thing for a web service like this is, it makes it easy for you to work with your technology teams because let's say they have their own release cycle, but you want to upgrade your model as new data comes in, and you don't want to wait for the IT release cycle. You can easily just change the model ID here, and you have your new model in production. Okay. With that, I complete my part of the demo. Bill, I will pass it back to you for Q&A.
Well, Raju, Connor, thank you for that excellent presentation. We'll get started with today's Q&A. And while we do that, I'm going to leave up this screen with contact information for Raju and Connor if you'd like to contact them following today's webinar. Now, I've had a lot of questions that have come in during the presentation, so we'll do our best to get through all of them in the time remaining. So let's get started. Connor, I think this one is for you. The audience is asking what data sources does Trifecta support? Specifically, does that include data from major web services like AWS, S3, or Azure?
Yes. So Trifecta supports data from S3, from all of your Azure file sources, blob, ADLS, as well as a variety of standard file formats: log, JSON, Avro, CSV, text, TSV. We really have designed the product to work with any source of data that you have, up to and including all of those cloud sources that you asked about, as well as a lot of traditional JDBC sources. So if you have a JDBC connector, you can plug that into Trifecta and access your data from those environments as well.
Well, thanks for that clarification. Now, you both talked quite a bit about transforming data, and a number of the audience members have pointed out that in practice, we understand that transforming data is actually a number of discrete steps. And the audience is asking which of your two platforms is able to do these steps, or perhaps is best to do each of these steps in data prep. And as I go through these stages, would you also comment on whether or not these particular tasks can be accomplished just by data scientists, or for example, are they simple enough to be done by line of business managers or SMEs? So the first one, of course, is blending different data sources, and Connor, Trifecta appears to be the choice for this one. Is that correct?
Yes, that is correct.
Okay. And then the second step that I would generally recognize would be cleaning, by which I mean the elimination of bad entries like nulls or incorrect formats.
Yeah, so as you might have seen Actually, you know what? I don't think I got to this in the demo today. But that's really something that Trifecta is extremely well suited for. We consider a lot of that cleansing process as something that you would do during the data preparation stage of your pipeline, just so that by the time you get to modeling, you're working with the most accurate data set that you possibly can. So a lot of that initial bulk cleaning, bulk scrubbing, we recommend doing that particular type of work in Trifecta.
Okay,
yes.
now does that require the skill level of an analyst or a data scientist, or could even a line of business manager do that?
Yeah, really any of the above. Trifecta is built to be extremely easy to use, very visual, and we actually borrow a lot of cues from Excel. So if your line of business manager, if your business analyst is familiar with Excel, they really should have the tool set to be able to work effectively in Trifecta.
Thank you. Now, the third step that I generally think about when I'm cleaning data are what I call transforms, like dealing with outliers, correcting badly skewed distributions, bucketing and binning, or log transforms, and that sort of thing. So where is that best done?
So this is a bit of a fuzzy line. There's aspects of that you would want to do up front in your data prep tool. So a lot of those initial cleansing activities, removing outliers, fixing really badly skewed distributions, you can do that in Trifecta. Now I think, as you saw in Raju's demo, some of the elements of that are a little bit more fine-grained. I think DataRobot can handle some of that later stage outlier handling as well.
Yeah, let me address that. So, by the way, yes, Trifecta is good in handling, missing values and not so well formatted data types and so on. However, DataRobot also has some capabilities in handling null values, NAs, missing values, doing right computations and imputations to handle anything that's missed on top of Trifecta. In addition, for outliers, there is, which I didn't show, but there is a way where you could see outliers if in case you're already in the DataRobot platform and you then thought about it. And in terms of log transformations or other variable transformations, sometimes it's hard for the user to figure what kind of transformations make sense. And that's where DataRobot shines. What it does is, when it does this exploratory data analysis, and it's looking for correlations and things like that, wherever it finds important correlations, it has some heuristics that are built in it, where it could do various transformations by itself, especially based on any skewness in the data or in the target, and thereby behind the scenes create some new features as it does it.
Okay, well, thank you. And of course, you mentioned the last category as you ended there, and that is what I think of as the final and artistic step of data prep is feature engineering. That is, creating features derived from other variables that weren't in the original set, like length of time since the last sale based on transaction dates, or ratios between variables. Where is that best done?
Yeah, so also a little bit of both tools. So I think, Roger, you alluded to the difference a little bit, which is Trifecta lets you sort of create all those variables for yourself. So experiment a little bit with feature engineering, create, some of those conditionals, or calculate the, difference in time periods. And all of that, we've got out-of-the-box functions to handle that. But I think the key difference between the two tools is the level of user input. So if you're experimenting and playing around with the feature engineering yourself, and by the time you don't necessarily want to have all of that work done automatically in the model, then a lot of that can be handled in Trifecta. But again, this is an area of overlap between the two tools. And if you know what you want to feature engineer, or if you kind of want to play around with your data yourself, then Trifecta is a really well-suited tool for that work.
Yeah, in my experience, you could, this is an area where you could use both the tools and get some great value. And the reason is like this. I completely agree with Connor in the sense there are times when, you want to do this in Trifecta. And those times are when you have a very good domain knowledge. You as a business analyst or a business executive or even data scientist, right, that knows this vertical, knows your data, and then you know that either by taking a ratio or differences or adding some features, especially when there are feature interactions and things like that, you could do that before you come into Data Robot and before you start the modeling. And Trifecta is a great tool to do that. In addition, let's say there are some feature interactions that you're not really aware of. That's when Data Robot does some feature engineering behind the scenes, Bill, where it looks at all important, not all the variables, but the variables that it feels are important, depending on the blueprint that it's using, and then does ratios, differences, additions, things like that automatically behind the scenes.
Well, that's terrific. Wow. That's exciting. So, Connor, the audience is asking, is Trifecta mostly used as a desktop app or a server version? Does it require an HPC environment? How much horsepower is required?
Great question. So we actually have 3 different product lines. So if you're working with small data, really desktop-sized, 100 megs roundabout, we do have a free desktop product called Trifecta Wrangler, and you can go to our website today and download that and play around with it. That is really well suited for small data that you have locally on your machine. We also have an edition called Trifecta Wrangler Pro. This is our cloud-based product, so it does run on Amazon or Azure. We also provide sort of a SaaS-style solution. So this is data a little bit more scaled up, possibly all in the cloud, really designed for team-based collaboration. And then finally, we have Wrangler Enterprise. So this is our sort of big daddy product. It can run on premises in a Hadoop environment. You can also spin that up on the cloud. There's also Trifecta. Google Data Prep powered by Trifecta is another cut of our enterprise product that runs on GCP. And this product comes with full connectivity to any of your relational sources, your cloud data, your Hadoop, Hive, or HDFS, as well as our most robust set of capabilities around workflow and automation. So 3 products, depending on sort of the size of your team, where your data lives, size of your data.
Well, thanks for that clarification. Now, kind of an extension of that, the audience is also wondering, is this processing in Trifecta, is the data physically extracted into Trifecta, or is this in database? And what does that imply about the size limits for very large files?
Yeah, so we don't move or copy the data anywhere. All of the processing occurs at the source. So if you're talking about extremely large data, hundreds of gigs or terabytes, typically we see that data in a Hadoop environment, or if you are on the cloud, you process that in something like Elastic MapReduce on Amazon. So since we are processing at the source, we leverage Spark, and that can scale to any size of data that you're working with in Trifecta. Similarly, if you just have very small data, so this is more our Trifecta Wrangler Pro edition, we do have a proprietary engine. Again, you're not moving the data into Trifecta, but you are moving it into our processing engine called Photon, and then piping that out to whatever your output file system is or output relational database. So data from the source isn't moved or copied. It does get processed in Spark or in Photon. Spark is for large scale, Photon for small, and then written out to wherever your output destination is.
Well, Connor, thanks for that clarification. Now, so Trifecta and Data Robot sounds like a good team. The audience is asking, can the data flow from Trifecta into Data Robot be automated? For example, if I was regularly updating my data, Could I set Trifecta to automatically run the recipe and then automatically pass that on to DataRobot that would refresh my model?
Totally. So Trifecta has scheduling in the UI as well as a set of REST-based APIs that if you're a little bit more technical, you can use those to schedule and kick off the jobs. And then, yeah, you can pass that data directly into DataRobot.
And Raju, will DataRobot then automatically receive and run that as soon as it sees it?
Yes, yeah. So we can, like I said, when I was doing the demo, that we can pick it up from, any local file or even from an S3 bucket, for example. So data that comes out of Trifecta, if it is placed in a location where, or even on Hadoop, we will be able to pick it up from there. So a scheduler, like since we have API provisions, the API can go fetch that data set from wherever it is and then be able to make predictions.
Well, thank you. Raju, another DataRobot question from the audience, and it's about how DataRobot goes about exporting its models to become operational. And in your demo, you talked about APIs. Are the models themselves otherwise exportable, and in what languages?
Yeah, so that's a great question, Bill. So the way it works right now is once the model is built, then we have something called a prediction server. So that's where the models will be exported, and then you can make calls directly to that prediction server, which is really optimized for making predictions. And there you could, again, use an API to make a real-time prediction by calling that server, or you could, if a batch prediction is a possibility, you can run them in batch, and it can score them for you very efficiently. So we have this concept of a modeling server and also a prediction server. Now, in terms of data export, we have if you move it from modeling server to prediction server, then you just move the model. But in some applications, we have seen clients asking for some code to be exported, and that's where we have this thing called DR Prime, DataRobot Prime. And with the click of a button, it's an additional service that you have to take, but it allows you to export code, for example, in Java. And you can just embed that, these algorithms that are built in DataRobot into your whichever environment you have, and then seamlessly make predictions from there.
Well, Raju, thanks for that clarification. The audience is particularly interested in how DataRobot goes about automatically detecting what right blueprint to use. For example, how does it detect the difference between classification regression or more confusingly, time series problems?
Yeah, that's another great question. So there are two questions in there. The first one is for DataRobot to figure which blueprint to use. These blueprints are created on the fly depending on the data set. So what it does is it has various heuristics that are built into this platform based on the experience of our really fantastic data scientists. And what it does is whether it be data preparation or automated feature engineering that we discussed earlier, or in calling the right algorithm, is all based on the blueprints that are created at that time after the data set is loaded. In terms of how it decides the classification versus regression versus time series, once the data set is loaded, depending on the target variable, it can easily decide whether it's classification or regression. But you can also overwrite from what it thinks it should be in case you want to do so. In addition, if it finds a time-based column in the data set, then it asks the user that whether they want to use time series based modeling because it has detected that, and based on it, they could make a selection as well.
Fascinating, fascinating, terrific stuff. One last question. The audience is asking, are there demo or trial versions available? Connor, I know you talked about the free Trifecta Wrangler download. Other demos from or free versions from both of you?
So the free Trifecta Wrangler download is a good option. If you do have cloud data, we also have, we consider it a free trial on the Amazon Marketplace. It's Trifecta Wrangler Pro, and you can give that a go as well.
For Data Robot, best way is to contact us through our web page or call us, and one of our account executives can work with you for make such a provision for you.
Well, Raju, Connor, hey, thank you. Some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Raju, Connor, and the Trifecta team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for June 26th, that's our next DSC webinar, Embrace the Modern Analytic Lifecycle. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Trifecta for their sponsorship, and particularly our speakers, Raju Penmacha and Connor Carreras, for their insight into today's topic. This is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June 26th. Have a great day.